or EMF, but the standard V represents any potential difference. So that's why we're going to use V in here and not E. Okay? If you get an Uglies book for electricians, you'll see on the front of that book it uses E for voltage. So those are interchangeable. You need to remember that E and V are interchangeable. Okay? But we're going to use V. All right? Charges, current. Current is charge in motion. Okay? That starts on page 35. All right. Page 36. Towards the bottom, it says the ampere of current. 3 sentences down, it says 6.25 times 10 to the 18th power electrons flowing past a given point per second. The value is 1 ampere. I will ask you that question on tests. I will ask you that question on quizzes. 6.25 times 10 to the 18th power electrons. Okay? Go down 2 more paragraphs, and right there it says the symbol for current is I, or little I, for intensity. So you might want to underline that, highlight that, notate that. Okay? So that's the amp. All right? Major things to us right now that we need to know. We need to know V. We need to know I. We need to know R. Okay? Very soon we're going to need to know W, which is watts. Okay? If you don't learn what these are, you're going to be lost real soon. Okay? That's your gas, brake, shifter. You better drive if you don't know what those are. Okay, so here we see some electrons moving through a piece of copper wire. Okay? Charge in motion. The amount of current is dependent upon the amount of voltage applied. Now we said that V and I are directly proportional. V and I are directly proportional. The more push we have, the more current we're going to have. Okay? But I and R are inversely proportional. So the more resistance we have, the less current we're going to have, right? Okay? So let's look at an example. All right, an example of this. Let's draw us a simple DC circuit. The short line is